So a rational function is a ratio of two polynomial functions. So if you take a fraction, make a fraction, we have a polynomial on top and a polynomial on the bottom, that is called a rational function, so long as that denominator is not 0. So here's an example of a rational function. We've got a quadratic on top, and then the denominator I wrote in factored form, but that's still a polynomial. It's just written in factored form. What would the degree of that denominator be? 3. Very good. Okay. So the domain of a rational function is a set of all real numbers except any x values that might make the denominator 0. Right? So we don't ever want to have a 0 in a denominator, so you just have to exclude those values. So in this case, what is the domain of the rational function? Everything but 0, 4, and -2. So you could write it in set builder. You could say the set of all x's such that x cannot be 0, 4, or -2. To me, that's a nicer way to write it. It's concise, but my math lab is going to ask you to put it in interval notation. So start thinking -infinity to infinity, and then we got to pull out these values. So it's going to be -infinity up to the first excluded value is -2, right? If you're moving left to right, you got to take out the -2. So we say up to -2, but not including that -2. Union that with -2 to my next 0 as I'm moving, I'm sorry, my next excluded value as I move from left to right would be 0. But don't include it because it's not in the domain. And then union that with 0 to, again, not including the 0, it's not in the domain. 4, don't include it, it's not in the domain. Union that with 4 to infinity. Yeah. It is not the most concise way to write this domain, but it means the same thing. We could put an equal sign in there, and those two sets are the same. Okay, so you can't have a 0 in a denominator, but we might be interested in what happens if you get the denominator really, really, really close to 0, right? You can put in anything as long as it's not 0 itself. So I want to think about this simple rational function 1 over x. And what value of x is excluded from the domain here? 0. Can't put a 0 in there. So let's fill in this table of values to see what happens to the y values of my function 1 over x as the x values get closer and closer to the excluded value of 0. Yeah, they're gonna get bigger, but let's do it out. Okay, so if I plug a 1 into 1 over x, what do I get? 1. 1 over 1 is 1. Okay. Plug in a half. What's 1 divided by a half? 2. You can type it into your calculator, or there's a couple ways to think about it. You can say, how many times does a half fit into 1? 2 times, right? Or you could do the flip and multiply, right? You might have to do a little side work. 1 divided by a half is the same thing as 1 times the reciprocal. 1 times 2 over 1, and either way you get 2. All right, what's 1 divided by 0.1? 10. What's 1 divided by 0.01? 100. What's 1 divided by 0.001? 1,000. So as my x values are getting smaller, as my x values are approaching 0, what values are f of x approaching? Infinity. They're just getting bigger and bigger and bigger. They're just going to go to infinity. So my x values are approaching 0, but if you picture a number line with 0 on it, I started over here at 1 and I got closer and closer and closer and closer and closer, right? But I was approaching from the right-hand side of 1, right? I only looked at what happened if I plugged in values that got closer and closer to 0 from the right. So if I was going to use notation for what I just calculated, I would say as x approaches 0, and you put that little plus to mean from the right, f of x approaches infinity. So let's see what happens as x approaches 0 from the left. What's 1 over -1? -1. 1 over -1/2? -2. 1 over negative 0.1 is negative 10, negative 100, negative 1,000. So as the x values approach 0 from the left side of 0, right, we start at negative 1 and get closer and closer and closer and closer, what's happening to my y values? They go to negative infinity. So my shorthand notation here is as x approaches 0, and that little negative sign up above means from the left. So you would read that as x approaches 0 from the left, f of x approaches negative infinity. Okay, so in this case, we have something called a vertical asymptote at the excluded value of 0. The function gets really, really big from the right and really, really small from the left, and you can never actually get to 0. Okay, so we know what happens near 0. Let's investigate some other characteristics of the graph. Does it have any x or y intercepts? No, neither, right? Because to find a y-intercept, you evaluate f of 0. You plug 0 in, right? Which is 1 over 0, which is undefined, right? So it doesn't ever touch the y-axis. And to find an x-intercept, you set the function equal to 0. Is there any x value that would make 1 divided by it equal 0? You can't divide by 0. 1 divided by 0 means nothing. No, yeah. The only time a fraction can be 0 is if the numerator is 0. And this numerator is always 1. You could also say, well, if I multiply both sides of this equation by x, I get 1 equals 0, which is impossible, right? So this is none. No x-intercepts, no y-intercepts. Okay, what's the end behavior of 1 over x? What happens as x gets really big, right? As x approaches infinity, the y values approach what? 0, yeah. 1 over, if you put in bigger and bigger numbers into the denominator, like 1 over 10, 1 over 100, 1 over 1,000, those values are getting really, really tiny. So they're approaching 0. And then as x approaches negative infinity, what's happening to f of x? It's still approaching 0. It's just coming through negative numbers towards 0. Here I was approaching 0 through positive numbers. So we have something called a horizontal asymptote because the end behavior at both ends is 0. It's called a horizontal asymptote. Okay, so I'm going to try to sketch a graph with all the information that I just gathered, right? I know that as x approaches 0 from the right, my function goes up to infinity. So I've got something like that. And as x approaches 0 from the left, it goes down to negative infinity. So I've got something like that. And I have my end behavior that as x approaches infinity, y approaches 0. So like that. And as x approaches negative infinity, y approaches 0 from below. What kind of symmetry does this thing have just by looking at its graph? Origin, yeah, it looks like if I fold over x and then fold over y, the two pieces would lay on top of each other. So we think this has origin symmetry or odd symmetry. Those are synonyms. Right, to confirm algebraically, if I plug a negative x into this function, I get 1 over negative x, right? Just replaced the x with a negative x. Is that the same as my original function? Is it the exact opposite of my original function? It is, because you can put a negative in any location of a fraction, the bottom, the top, or out front. So this would be negative 1 over x, which is the exact opposite of my original function. right? That's the definition of origin symmetry, right? If we plug in a negative x and you get the exact opposite of your original function. So this is a parent function. This is going to be a new parent function to add to your list. And in your activities, I'm going to have you do some transformations of this new parent function. Stretching, shrinking, shifting around. Is that okay? Make sense? All right, so now we're going to develop one more new parent function. F of x is 1 over x squared. What value is excluded from the domain of 1 over x squared? 0. Can't plug in a 0. Okay. So let's think about what happens as we approach that excluded value from either side. Right. So I'm going to say as x approaches 0 from the right. So as I plug in smaller and smaller values of x, like 0.1, 0.01, 0.001, what happens to 1 over x squared? Which one, Nico? Can't do both. Gets big. If you have a small denominator, then the fraction is actually going to get really big. Like 1 divided by 0.1 is 10. 1 divided by 0.01 is 100, right? So as you make denominators smaller, the value of the fraction gets bigger. So this thing is going to approach infinity. And what about as x approaches 0 from the left? Yeah, it's the same. With the other one, it was negative infinity. Why is this one positive? Because you're squaring, it's going to take, even if you're plugging in negative values for x, you're going to square them, and then it becomes positive. So this goes to positive infinity. So that's what happens as I approach 0 from the left and the right. Think about the x-axis as I'm approaching the middle, it shoots up. So I have a vertical asymptote at 0 again. So let's think about the end behavior, right? As x approaches infinity, what does f of x do? So I'm making my denominator get really, really, really big. Nope. 0. Yeah. When the denominator gets really, really, really big, so this is like, if you plugged in a 10 for x, this would be 1 over 100. If you plug in 100 for x, this would be 1 over 10,000. So my y values are getting really, really small as my x values get big. And then as x approaches negative infinity, what does f of x do? It also approaches 0. Yep. Because again, if you plug in negatives, you're squaring them, you're just going to get positives, and it's going to do exactly the same thing as you did from the right. Or as x was going to positive infinity. Okay, so where's my horizontal asymptote? Yeah, y equals 0. You can tell from the end behavior, right? That's your asymptote. Does it have any x or y intercepts? No. You can't plug a 0 in for x, and if you set this thing equal to 0, it has no solutions. So this is neither, none. Okay, so if I wanted to sketch this, I would know that as I approach 0 from the left and from the right, it shoots up, goes to infinity. And then as x goes to infinity and as x goes to negative infinity, the function approaches 0, the horizontal asymptote of 0. So it looks something like that. What kind of symmetry does that graph appear to have? Y-axis or even? So let's confirm it algebraically. To find symmetry, you always just plug in negative x. So this is going to be 1 over negative x squared. And what do you get when you take a negative number and square it? A positive. So this is 1 over x squared, which is exactly my original function. Right, that's exactly what I started with, so I've confirmed this is y-axis symmetry. Any questions? All right, I'm going to have you do some playing around with these two new parent functions. This is another new parent function, and you're going to do some transformations on these.